So this section, we are talking about exponential functions. I'm going to switch over here to the one I can write on. So we're going to look at exponential growth and decay, rate of change, and we're going to eventually use our properties of exponents. So just a reminder, an exponential function has x as the variable and the exponent. So an example would be y equals 3 to the x. Our variable is the exponent. That's what makes an exponential function. So exponential growth is when something increases exponentially, so that it goes up really fast. And then exponential decay is when something decreases. So that's like the half-life in science is when you usually see that. But it goes down, 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 and then it kind of flattens out. So in this section, we're going to look at 3 equations, and they're all exponential because we have a variable as our exponent. So the growth equation, y equals a1 plus r, and then the exponential decay, the only difference is a minus. So A is our initial amount. R is our growth rate in this situation. And T is time. So over here it's the same. It's our initial amount. Except now this is our decay rate. And T is time. So just a quick note, when we talk about rates, R, usually we're given a percentage. Like say we're given 6%. Our R value would be the decimal version of that. So remember, to write a percent as a decimal, you put your place value period at the end and move it back 2 spots. So 6%, R would be 0.06. That's what you would use in your equation. So if you see just random equation, the way you tell if it's growth or decay is you look at what's in the parentheses. So the 1 plus r, 1 minus r, if this value is greater than 1, then it's growth. If it's less than 1, it's decay. So for example, if I have an equation that's 2 times 3 to the x and 2 times 1/3 to the x, this would be growth because that 3 is greater than 1. This would be decay because 1/3 is less than 1. That's a quick way to tell just by looking at your equation. Okay, last one, we're going to look at compound interest. So money, if you put money in a bank account and you're getting paid interest, that's exponential growth. So P is what we call our principal. That's still our initial amount. R is the rate, the interest rate. And the same rules apply, like our 6% here, you would write it as a decimal. N is the amount per year that the interest is compounded. So we're going to say amount of compounds per year. So, and T is time. So I'm going to go back to the end part, amount of compounds per year. If something is compounded annually, that's once. Semi-annually, twice. Bi-yearly, or is the same as semi-annual. But if it's monthly, 12. So how many times per year is it compounded?